So example 3. Find the arc length function for y equals x squared minus 1/8 natural log of x, okay, with initial point one. And we can check when x equals 1, natural log of 1 is 0, so we have y equals 1 squared, or y equals 1. All right, so let's see how we work this out. We know that if I'm looking, this is the previous page, we are looking at the arc length function, and as before I have the radical, and inside the radical I have 1 plus the square of the derivative. So let's find the derivative, square it, and add 1 to it. So, what is 1 plus f prime squared? Well, it will be 1 plus. Now we squared x squared. We need first to take the derivative and then square it. So, let's take the derivative first. So it would be 2x, and then minus 1/8 the derivative of natural log of x, but the derivative of natural log of x is 1 over x, so we have 1 minus 8x, and now we square it. Okay, so far you're with me? And then here we have 1, and now we squared. So we squared and we have 4x squared, and then we have plus, this is minus. No, actually, yeah, it's minus because the function is minus. So minus 2 times 2x times 1 over 8x, right? This is a and this is b, so it will be 2ab. And then plus b squared, which is 1 over 64x squared. Okay. And now we continue to manipulate this, and we have 1 plus what? We have 4x squared. And look here, you have 4x over 8x, so that will be 1/2. So we have 1 minus 1/2, and here we stay with 1 over 64x squared. The square of a minus b is a squared minus 2ab plus b squared. That's the algebra part that comes and bite you in the rear end if you don't really have a complete command of these sort of things. All right, so now I have 1 minus 1/2. I'm going to write it as 4x squared. I'm going to keep that term in the middle. 4x squared plus 1/2 plus 1 over 64x squared. Can you tell what's coming next? Look at this expression. Remember, when we had 2x minus 1 over 8x squared, we end up having 4x squared minus 1/2 plus 1 over 64x squared. Now we have 4x squared plus 1/2. It is the same thing with a change of sign. Instead of negative 1/2, we have positive 1/2. So I can write it, if you don't see it, I can write it as plus 2 times 2x times 1 over 8x plus 1 over 64x squared. You see, this is still plus 1/2. But what I have here is a squared plus 2ab plus b squared. So we have a square of a binomial. So we have 2x plus 1 over 8x squared. And this is good because, remember, this is the radicand of the function. So it's very, very good results for us. Now, we're going to say that the function is the integral from a to x. A is 1, from 1 to x, of the square root of this thing. So now this is fairly simple integral, right? So it will be the integral of 2x is 2 times 1 half x squared. So we have x squared, and then the integral of 1 over x is the natural log of x. So we have plus 1/8 natural log of x, and this is evaluated from 1 to x. Okay, so we're almost home. So we have x squared plus 1 over 8 natural log of x, and now when we evaluate it for 1, then we have minus 1 squared, and then the natural log of 1 is 0, and that's it. Okay, the correct version here, for example, if we let x equal 4, then the arc length from x equals 1 to x equals 4 is given by, so it's given by, and if you ignore this, and then we have simply s of 4, so L, the arc length equal s of 4, and all we need to do is plug it in. And we end up having the same result. It's not that the result is not incorrect, but what I did here is unnecessary because we have 4 squared plus 1/8 natural log of 4 minus 1. So it's still going to be 16 plus 1/8 natural log of 4 minus 1, or 15 plus 1/8 natural log of 4. Okay. So, again, the result is the same, but these steps here were not necessary because the whole idea, once we have a function, we substitute x with the upper boundary or the final point, the end point, and we get immediately the answer.